Here we go. You should have did it on your phone.
My phone don't work on.
Oh, okay. It's Canvas. All right, so 3.1D properties of logs. We're going to start here. So we're going to start with a little review from reiterating some things and kind of making it hopefully solid in your brain from December, that logs and exponents have corresponding properties. And the reason being, first off, is that logarithm is the exponent to which b must be raised to. Remember saying that? When you have a log, you're saying to yourself, b to what power equals m, right? And so remembering that that's the relationship, b to what power. All right. So when we look here, we have the logarithm log base b of x equals y. Okay, log base b of x equals y can be written as an exponential x equals b to the y. The best way to remember that is I call it the arrow test, okay? So your base of your exponent is the base of your log. The power of your exponent is the output of it. So the base of my exponent of my log is b. The output is y, and what's left is your solution of your exponent. Okay, this is a log given any base as long as b is not equal to 1, right? All right. Or and greater than 0, so positive. Natural log. Natural log is ln of x. Natural log is saying that you have log base e of x equals y. Okay, so again, the base of your e to the power of your y. And what's left is your x. That's why the exponential version of natural log of x equals y is x equals e to the y. Okay, natural log is the same thing as log base e. However, remember, mathematicians are a little lazy. So the least amount of characters we can have, the better. So someone decided that log base e equals ln. So instead of writing log base e, they start writing ln, which is natural log. Okay, and we say natural log, but it's written as ln because pretty much every nation, language in the world, they put the verb before the adjective, except in America, we put the adjective, then the verb, right? We say pretty girl instead of girl pretty. Yeah, correct. Okay, and so that's why it's ln, because it'll be log de natural or log natural or whatever in most places besides here. Got it?
So log x equals y. X equals e to the y.
On the common log?
Natural log.
Natural log. It will be e to the y. Yeah. All right. Common log. Common log means that you have an invisible base, and that invisible base equals 10. Okay. For common log, your invisible base equals 10. So that's why when you end up writing it as an exponential, it becomes 10 to the y. That's because there's an invisible 10. So you're saying 10 to what power equals x?
So it will be 10y.
It will be 10 to the y. Okay, before I give you a chance to practice on your own, we're going to do a whole class example first, right? All right, so here we go. I'm going to write it out, and I want you to say it out loud if you're confident, okay? So if you had log 5 x equals y, how would I write that as an exponent? Say it again. Exactly. So as an exponential, this would become 5 to the y equals x. The base of the log to the output, carried to the output, equals your argument. We did it in December. Remember I said I'm going to bring back December? Can't assume we remember, right? The what? Your base? Yes, the base of your log is the base of your exponent. Okay. All right. I'm going to give you 90 seconds to work with your table and rewrite these logs as exponentials. Mm-hmm. 1, 2, and 3. So you're going to write the exponentials as All right, so here on the first one, again, your base to your output. And what was my output?
4.
What was my output?
Oh, that's
2. My base is 4. Output equals my argument, which is 16. That is very true, right? Okay.
Wait, so 4 is the base, 2 is output.
Uh-huh.
65.
Mm-hmm.
Okay.
My base to my output
5.
and my argument was 7. Okay. Natural log. Natural log, remember, it's log base E, C equals 3. Okay. Natural log means that you have a base of E. Okay. So again, following the same rule, my base is E, my output is 3, and my argument is C. So we end up with E to the third equals C. How we do? Doable? Okay. All right. Now we're going to go vice versa. So what if you're, yes. Exactly. When there's no number, your base is automatically 10. Okay. All right. We're going to go the other way. What if you're given the exponential? How can you find the log? Same thing. It's your base and your output is your argument. Do we see that? What does the base of my log have to be? 2. So log base 2. What is my argument now? 1/8. And your exponent becomes your output. You're going the other way. You're reversing it. Okay. So again, my base, my argument. So log 10, argument is 1, and your power was 0. This can also just be written as log of 1 equals 0. Because of the 10. 10 has the power to become invisible with log. All right, it's E. So instead of a log, what is it going to be? Natural log. But if you need to write it out as log, that is okay. Does that make sense? So if I need to do base argument, so log base E of 12 equals A. So therefore, it'll be natural log of 12 equals A. Because when you're writing it in log, 12 is your argument. Because 12 isn't my base. My base is E. It's still, 12 is still my argument.
LN is the log.
LN is your log. LN is replacing log base E. Okay, so 12 is your argument, not your base. Okay. All right, so that's going back and forth between exponential and log to exponential form. Okay. All right. Now, next, simplifying log expressions. So we're going to open our little booklet. We're on the back. We're going to be simplifying log expressions. Oh, yeah. I actually printed it correctly today.
The homework is due tomorrow, right? Thursday? Or tomorrow?
Thursday. All right. So we're going to go through our properties. There are 5 properties of logs. How many? 5. Okay. We're going to start our first 2 properties. Our first 2 properties are called our inverse properties. Okay. There are inverse properties. They should be the same. Open it. Property 1. Property 1 is the exponent inverse. Okay. If I want to get rid of the exponent, I'm going to raise it to that log with the same base. So notice how the base of my exponent and the base of my log are the same. Guess what they're going to do to each other? They cancel out. And what I'm left with is just the argument. Do we see that? So when this happens, my solution is the argument.
So it's log L equals
Okay.
or did the log cancel out?
The log canceled out. Okay, now let's look at property 2, the log inverse. Okay, Again, I have log base b of b to the m. The base of my log and the base of my exponent are the same. So they're going to cancel each other out, and I'm just left with the exponent as my solution. Okay, that's what it means when we say log and exponentials are inverses of each other. They are used to cancel each other out. Okay, I like to think of it as like saying tag, ha ha ha, you're out. Tag, you're out. Okay. All right, so let's practice the inverse skill. So here, I have 5 raised to the log base 5 of 18. The base of my exponent and the base of my log are the same. So what happens here? It cancels out, and my argument is my answer. This is because of property 1, inverse.
So number 2 would be negative 2.
No,
Oh, be log negative 2.
it'll be
Log x negative 2.
x minus 2. Okay, let's see it. Again, base of my log, base of my exponent are the same. They're going to cancel out, and everything that I'm left with as the power is my answer. Okay, not just part of the power, the entire power is my solution, my
Why did you
result.
do property 1?
Because property 1 is our exponential property.
Oh, you
Property
wanna
2
do
is our, yeah,
you
we're
wanna label
justifying, yes. Okay, do you think those rules are going to change just because of natural log?
No.
No, it does not. Anytime natural log and e are touching each other, guess what? They cancel each other out. Natural log and e, what are they going to do? Cancel each other out. And in this my power is my solution, my result. Okay, and this is an example of natural log with property 2. Good job. Okay, again, anytime e and natural log tag each other, they are canceling each other out. So my argument is my solution, and that's property 1. When your argument is your solution, that's inverse property 1. When your exponent is your solution, that's inverse property 2. Got it? How do we feel about the inverse rule? Pretty good? Doable? All right, now we're going to move on to property number 3. Okay? Properties 3, 4, and 5 follow our exponent rules. So look right here as an example. This is called our product rule. Okay, the product rule is saying if you're multiplying 2 exponents, what are you doing to their powers? Adding them. So guess what? If you're multiplying 2 arguments, guess what you're doing with their logs? Adding them. Okay, so I can expand them to addition. So this is called expanding. So I can expand them to addition. So let's look at this example. We have log base 4, 5 times x. How can I expand this? Okay, log base 4. Say it again. 5. Perfect. Plus log base 4x. Because I can take the multiplication and turn it into addition. All right, so now,
Why did 1 have x?
because it's 5 times x and we separated it, we expanded it to an addition problem. So you're taking one factor and the other factor and making, okay? All right, now we're gonna go the other way. So, using the wrong colors. So now, if I want to condense, I'm gonna pay attention to what I have. Since I'm adding the 2 logs, I can condense them by multiplying to make it into 1 log. So here, notice that the bases are the same. So we're gonna have log base 2, and I'm gonna multiply my arguments. So 6 times, we're gonna simplify. We can't solve because there's no equal. You only solve when there is an equal. You're evaluating or simplifying otherwise, okay? All right, 6 times 10 is what? So my single log is log squared log base 2 of 60. Didn't say log. It's not squared. That was a bad term. Don't ever use that again. I was hoping no one caught on to that. No, you didn't. You heard log base 2 of 60. All right. How do we feel about product rule? Are we okay with it? All right, let's do an out loud check really quick. Ready? So we're gonna do. All right, it says log base 2, 5x. Out loud. How does that expand?
Log base 5, 2. Wait, log base 2, 5, log base 2, 8.
There we go. They separate. You take the one factor, which is your coefficient, and you take the other factor, which is your variable, right? And we separate, okay? This is going to be important for when we get to our transformations, okay?
This stuff better be on our test.
And you know, this is the stuff they told me to teach you guys. I'm teaching you what I'm being told to teach you. It's not my fault. It's not my fault. No, it's not my fault. Y'all can see my teacher manual that I live in. And I'm like, okay. All right, so we did product. Now we're on to quotient. Good job. You're right. Quotient. Okay. All right, so quotient works the other way. It's like the exponent rule. So our exponent rule, when you're dividing two exponents, what are you doing to their powers? You're subtracting. When you're dividing two arguments, what are you doing to their logs? You're subtracting. You don't say.
The log properties are basically almost the same.
Yeah, if only your teacher didn't write that on your paper above property 3.
Oh.
All right. All right. So on my notes, I did natural log, and I think on y'all's, I switched it to log. So go ahead and eliminate natural log and just write log. Is it going to change just because I wrote that? No. Yeah, it's just log base 10. Okay. It's common log. All right. So how can I expand this guy? Log base 10 of 6.
Where the
10 is what? Invisible. It's the common log. 10 is invisible.
Oh, we don't have.
Anytime there isn't one, it's invisible. All right. Now let's go the other way. What if I want to condense a subtraction?
It'll be a log.
A 1 log. And order matters, right? The first argument divided by the second argument. Order matters with division. So 50 divided by, and what does that give me? 2. Perfect. Log base 10 of 2.
Oh, you don't have a base. That's what
It's 10. When there isn't a base there, the value is 10. Okay? All right, let's do a quick little out loud before we keep going. Are y'all ready? Okay, we're gonna do log. All right, I have log 40 minus log 10. Log 2. How can I consolidate that? Log base what? Log base. There we go. Tell us why. Exactly. When we're subtracting the logs of the same base, we're dividing the arguments, right? Subtracting the logs of the same base means we're dividing the arguments. So 40 divided by 2 is 20. And that's how we condense it. Got it? All right. Our last property is property 5. It's called our power property. Power. Okay, it's our power property. So looking back at exponents, when you have a power, an exponent with a power, you multiply, right? Okay, logs work the same, except you're going to be multiplying that log, which means that the power becomes a coefficient. Okay, so when you are expanding, the power becomes a coefficient. So looking here, my power becomes my coefficient, which just makes this what?
3 log.
3 log x. Okay, this is going to be important for tomorrow. All right. When you're condensing, you're going the other way. You're turning your coefficient into your power. Okay. When you're condensing, you're turning your coefficient into your power. So what is our coefficient? 2. So it becomes log base 2, 3 squared. What is that? 3 squared is 9. And you simplify if you can. Can I simplify 3 squared? Yes. So I'm going to write it as log base 2 of 9. All right. You're going to always choose the simplified. The most simplified. Good question. All right. Let's put them all together. Okay. When you are trying to condense as much as you can, there are 3 rules you're going to follow. Step 1 is you're going to use property 5 first, always. So you're going to ask yourself, can I apply the power rule? Step 2 is you're then going to ask which property 3 or 4 are you using? Are you using product or are you using quotient? And then step 3 is to check for property 1. Is there anything that cancels each other out? Okay. Product or quotient. All right, so here we go. First step is to check for property 5. Property 1 inverse. I didn't finish writing it. So we're going to check for property 5. Are there coefficients that can become powers?
No.
Yes, I have 3 can become the power of Q and 6 can become the power of V. So we have log B, just B, Q to the 3rd plus log base B, V to the 6th. Okay. So after you did property 5, you're now going to check, are you using product or quotient? Well, it's plus, so we're using, it's plus product. So we're going to end up multiplying. So to condense, I'm going to multiply same base, log base B, and I'm multiplying Q to the 3rd times V to the 6th. And that is me condensing down to 1 log. Because they have the same base. Yes, so I want y'all to try before we go over 2 together. I want you to try. Okay, let's quickly go over it. So checking property 1. Can I apply property 5? I'm sorry. Yes. You get a 4 as your power and you get a 6 as your power. So that gives me log x to the 4 minus log x plus 2 to the 6th. You cannot distribute over addition and subtraction. This literally means you have x plus 2 times 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 x plus 2. And we're not going to do that math, okay? We're going to leave it as it is, okay? All right, next, you're going to check, is this quotient or product? Quotient. So it's going to lead to me having to 1 base, but we are dividing our arguments. X to the 4 divided by x plus 2 to the 6. And that is it. There's no log, the base isn't there. So what's the base? 10. Remember, even though you don't see it, who's there? 10. Don't give it a base. If it's not there, it has a base of 10. If it bothers you, write 10. Okay, if it bothers you, you can write in 10. Okay, I would not count off on it as long as you understand that when you don't see a 10, that is still there. Okay, all right. Okay, Last thing is reminding you that even if you are working a log function, even though you may not have a TI-84 or Inspire at home, you can always find the log of anything, just making sure you change the base, okay? So if I have log base 3 of 91, I can write it as log of 91 divided by log of 3, and I'm going to find my answer. Does that make sense? Okay, your argument is in the numerator, your base is in the denominator. Okay, so again, on 2, let's talk about it as a class. I have log base 2 of 81. If I have a non-calculator, I can change write in the base with, what do I write it as? Good job. Log of 81 divided by log of 2. Okay, I can find the log of any base as long as I rewrite it in base form, in non-base form. All right, so we were supposed to have time to do the class practice, but we did not. So this is class practice / exit ticket. What I want you to do is to practice these problems to make sure that you really understood the assignment, okay? It's not for a grade, and it's strictly for you to check your knowledge. Okay, so check your knowledge, and I will have answers up tomorrow where you can check yourself, okay? All right.
Our quiz is just over yesterday and today.